welcome. We are going to take this time to look at identifying and classifying polygons. So at the beginning of this activity, you're going to see a lot of questions about regular polygons. And so just to kind of review what a regular polygon is going to look like, a regular polygon it's going to be considered regular if all of its sides have the same length, okay, and all of its angles have the same measure. So a regular polygon with 8 sides is going to look like this. We can see our angles here. Okay, there's going to be, they all look to be about the same, even though there's not any measurements we can see. And then the sides, we can see that these are all going to be similar in length as well. So since all of the sides have the same length and all of its angles have the same measure, we would say that this would be considered a regular polygon. Now, when you're determining if it's considered regular or not, that's what you want to look for, is those angle measures and those side measures. And even though there's not measurements, we can look and kind of determine if it would be considered regular, if they would be the same lengths. So when we look at this question, it says, is this shape a regular polygon? Okay, so all of the sides and all of the angle measures, they have to be equal. When we look at the angle measures, we can see this appears to be an obtuse angle. This is definitely an obtuse angle, but then we come over here and we've got a couple of acute angles. Remember, obtuse angles are greater than 90 degrees. Acute angles are less than 90 degrees. And then right angles are equal to 90 degrees. So since we have kind of a range in our angle measures and these acute angles, we don't know if they would be the same, but we know that they're not going to be the same as the obtuse angles. So, and we can also look at these side lengths and we see that this one is a very long side length, but then this one is a little bit shorter. These are not going to be the same length. So since the sides do not have the same length, all of the sides have the same length and all of the angles do not have the same measure, we would say that this is not a regular polygon. So we would say no. It does have different side lengths and it does have different angle measurements. Going to another example, is this shape a regular polygon? And we could see here, if we look at the angles, these appear to be the same size, okay, same angle measure. We can also see that the side lengths appear to have the same measurement as well. And so since the sides have the same length and the angles have the same measure, we would say that this is going to be classified as a regular polygon. We go to this next question, is this a regular polygon? And we can see that, okay, this appears to be an obtuse angle, but then this one is an acute angle. And so remember, obtuse is greater than 90 degrees, acute is less than 90 degrees. And so it does appear that the sides might be the same length. We're not really too sure, but those angle measures are not going to be the same measurement. And so we would say that this is not a regular polygon. And one more with regular polygons. So in this case, if we look at these angle measures of this shape, we can see these appear to be the same. It also appears that the side lengths are the same as well. So since all of its sides have the same length, all of its angles have the same measure, we could classify this as a regular polygon. Now, when we move through this activity, we're going to also see some questions that just ask, is this a polygon? Okay. So when we go to this next question, it says, is this a polygon? We have to remember that a polygon is a closed figure with straight sides, okay? A closed figure is going to start and end at the same point. And so we could say that maybe this is the starting point. We follow this over to this point here, follow this here, and then we end here to connect all the sides. Now, I know a lot of you are looking at this saying, well, this is a triangle. Triangle is a form of a polygon. So these angle measures appear to be the same measurement. These sides appear to be the same. Now, it's important to remember, though, that not all triangles are going to be considered regular, okay? In this case, it does appear that this is also a regular polygon, but in some cases, it might just be considered a polygon, okay? So in this case, this figure is considered a polygon. As we move to the next question, we have to remember that a polygon is a closed figure with straight sides. So this figure does appear to be closed. All of the sides are connected. However, when we kind of trace around this figure, you can see there's a lot of curves with this figure, which means that the sides are not straight. And so in this case, this is not a polygon. Okay, and then is this one a polygon? So remember, a polygon has it is a closed figure. And so if we started at this point here, we trace this figure here and go up and over this way, we stop at this point and those points do not connect. And so that leaves this figure open, okay? A closed figure is going to start and end at the same point. And so since this is not closed, this would not be considered a polygon. Now, this next chart, I think this is really important that you save this. This is going to be very helpful for some of the questions. So I'd encourage you to take a screenshot of this. I am going to go through some examples, but then I will also come back to this so that if you were not able to screenshot this, also you can pause this video, take a picture of this. This is going to be very helpful. Some of these shapes we might know the names of, but seeing the names and the sides go together is going to be very helpful with a lot of these questions. So in this case, we have triangles with 3 sides, quadrilaterals with 4 sides, pentagons with 5 sides, hexagons with 6 sides, heptagons with 7 sides, octagons with 8 sides, nanogons with 9 sides, decagons with 10 sides, and dodecagons with 12 sides. So some of the questions are going to ask you, like in this case, it's how many sides does a quadrilateral have? So I'm going to look back at my chart and I'm going to see, okay, I have a quadrilateral here, and that's going to tell me that I'm going to have 4 sides. So I would say that my quadrilateral has 4 sides. If I move to the next question, sometimes they are going to ask to set up operations, okay? And so in this case, it's important to really look at this question. It says, how many sides do 1 nanogon, 1 hexagon, 1 decagon, and 2 dodecagons have in all? Okay, so all of the sides combined together means we are going to add up all of these sides and decide how many sides there are total. And so the first thing we want to do is we need to find the number of sides for each group of shapes. So if I have 1 nanogon, I have 9 sides. 1 nanogon, 9 sides. That is going to give me 9 sides total for the nanogon. Okay. And I'm just going to cross this off up here so I know where I'm going next. 1 hexagon. So I'm going to come over here to hexagon. And I have 6 sides. I'll underline this. I have 6 sides, which is going to give me 6 sides total. Now I have 1 decagon, which is going to be a total of 10 sides. So 1 and 10 is going to give me 10 sides total. And then I have 2 dodecagons. So 2 dodecagons is going to be 12 sides each. So I would end up taking this and multiplying it by 12 to give me a total of 24 sides. Once I have all of my sides listed, now I can add those numbers together to find the total number of sides. So 9 plus 6 plus 10 plus 24 is going to give me a total of 49 sides in all. So it's important to keep in mind to pay attention if it's asking you for all of the sides total, or if it's asking for a difference in the total amount of sides. The next question, again, this is where it's important to read the question and see what is it asking. So how many more sides does a decagon have than a quadrilateral? So if it's asking how many more sides, this is going to tell you that you're going to be subtracting, okay? And so you're going to subtract this first shape, and you're going to subtract the second shape from that. So a decagon is going to have 10 sides here, and then a quadrilateral is going to have 4 sides. So we would say 10 minus 4 is going to give us a total of 6 sides. So that would mean that a decagon has 6 more sides than a quadrilateral, okay? So this is where, again, it's very important to look at those words of the question if we're asking for all of the sides in all, or if we're asking for how many more sides does one have than the other. So I am going to put this back up. If you were not able to take a screenshot of this, now you've seen a couple of examples, you could see how this is going to be a very helpful chart to answer a lot of these questions. I would encourage you to make sure that you save this and have this available for you to refer back to.